Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this third lecture of Module 5 on Engineering Geology of Dams and Forces Acting on Dam. In our previous discussions, we have elucidated different types of dam based on material used, and in these lectures we will explain about classification of dams based on design and function. In these lectures, we are going to classify dams in view of design and function or principles of working. In this lecture, we are going to cover about classification based on design and function concerned to gravity dam, arch dam and embankment dam based on design as well as working principle / function. Friends, before these discussions we have categorized different type of dam based on material used. Today we are going to elaborate about the categorization concerned to design and working principle or function. The dams can be categorized as gravity dam, as arch dam, as embankment dam, and in addition to this we have some miscellaneous type of minor dam similar to the design based structure of dam. So first we are going to elaborate about gravity dam. Gravity dam is a very ideal type of dam. It is also called as engineer dam. Here you can see this is one view. This cartoon is representing a view of gravity dam. This gravity dam, you can see this part is almost straight in nature, and this part is straight or sometimes curved also. Sometimes curved also in nature. Generally some part is vertical and then some part is inclined. In some cases, we will discuss in our next lecture, in some cases this portion also some inclined. In general, this is the view of a gravity dam. This is a view of gravity dam which we are going to see. This type of dam generally be preferred to develop in this narrow valley. Here I have prepared this cartoon for representing valley. Narrow V-shaped valley is referred for such type of construction. As the name indicates, it is a gravity dam, therefore this type of structures generally constructed with help of concrete and others. So one by one we are going to elaborate about the material used for constructing a gravity dam, then about geometry of gravity dam, then about principle of working concerned to gravity dam. If we are going to see this structure, these structures require concrete for construction or masonry having good density, so that this structure should be heavy in nature, following the gravitational pull towards the bottom side to hold whole structure suitably. In almost every situation, here you can see this lateral view. This is a gravity dam. and this upstream side, this is the lower stream side, this is left abutment, this is the right abutment. So this is the lateral section and this is the vertical sections, cut sections we are going to take. If you are going to draw a section along this, then we are getting this type of approach. So one by one we are going to elaborate. This gravity dams are constructed by concrete generally, sometimes masonry also. The use of concrete to construct a gravity dam, which is a thick and heavy concrete body, triangular or trapezoidal in shape, with base width approximately 2 by 3 times their height. Width 2 by 3 times h height. In these dams, the axes are straight or slightly curved. The upstream face of dam are straight and vertical or combination of straight and inclined face. However, the downstream face of gravity dam are straight or curved in nature. Here, if we try to draw this, we can see this type of section we are getting, this type of triangular section, here upstream side, here downstream side, or trapezoidal section, generally trapezoidal section, this type of section. This whole thing is made up of concrete. Concrete we have already discussed. Concrete is equal to aggregate plus cement plus water. The water present in this reservoir side. Principle of working and function. This type of dam is a thick and heavy concrete body, provides high downward acting force due to gravitational pull. That is equal here, the gravitational pull is representing downward acting force F downward. F downward is nothing, it is simply weight of dam. And weight of dam can be easily calculated if we are going to observe the unit weight of concrete and the whole geometry about the volume of material utilized for construction of such dam. This gravitational force or gravity force should be sufficient to encounter other adverse forces like horizontal hydrostatic force, shield pressure or shield force, earthquake pressure or earthquake force or force caused by seismic activity, force caused by the dynamic state of water, force caused by ice, change in state of water, etc. So in all situations, here I try to show through this cartoon. In all situations, suppose this is the gravity dam, symbolic section of gravity dam. This is the downstream side, this is the upstream side. The water present here, the pressure due to water is acting on this dam body, going to push this structure downward toward the downstream side. The silt deposit also going to create pressure on the dam body and try to push this toward the downside. During the earthquake, this whole structure is moving up and down and back and fro. In this way also, this downwards moving component of the force due to earthquake is going to push this structure or topple this structure. If The gravitational pull or the gravity force of a structure, here the weight of the structure FWT, weight of the structure acting downward, is sufficient to encounter the horizontal hydrostatic force, horizontal hydrodynamic force, and force due to ice formation of the superficial part, force due to wave action, force due to other causes, vibrations and others, can countered by force caused by weight of structure. Therefore, this type of structure which is following the countering of all the summation of all the expected forces acting to disturb the dam, countered by this downward acting force. Therefore, this structure is made up of concrete or masonry of high density, so that the weight of structure can be sufficiently or can sufficient counter all the disturbing forces expected to act on. Another point, if this structure is heavy in nature, if this structure is heavy in nature, then but natural, if this structure is heavy in nature, therefore this ground should be very strong and competent and durable in nature. So what is the condition in which this type of dam is suitable to construct? The good to excellent category of rock strata located in long and narrow valley are the perfect geoground or site for construction of gravity. We have already discussed about the quality of rock mass or rock strata based on Q system, based on RMR system. In that system, this type of dam foundations require or foundation strata requires good to excellent category of rock mass or rock strata located in long and narrow valley. Long and narrow valley encountering good to excellent category of rock strata is recommended for construction of gravity dam, because this type of ground is able to bear the load of heavy concrete structure. However, strata of poor or moderate categories, also moderate category like bedded ground, bedded sedimentary ground or layered igneous ground, others can be also utilized if the valley is narrow, because if the valley is wider, then more material is required, that is not economically and time taking also and costly also. In all respect, the wide valley is not recommended for construction of gravity dam in general. However, if the requirement is necessary, then it is engineered dam, and ideal dam can be constructed by taking lot of treatment, preparations and others. So in case of strata, poor and moderate category like bedded ground, we have already discussed different type of bedded ground, layered ground, heterogeneous bedded ground, etc. Bedded sedimentary ground requires some proper preparation and high level of treatment before placing the gravity structure like gravity dam. So in any situation, this dam can be created but not economical. It prefer to construct in narrow and long valley, which is comprises of good and excellent category quality of rock strata. Then what is the benefit or advantage? Advantage. The gravity dam can endure minor over-toppling flow without damage due to nature of concrete resistance to scoring. So problem of over-toppling is a critical in field of dam. So this type of dam is going to show its stability against the over-toppling activity, particularly in case of the minor endurance. The life of gravity dams are more in comparison to other type of dam. Gravity dams are commonly used for multi-purpose because we have to recover our money involved in the project. Therefore, such type of project generally prefer for the multi-purpose. What is the disadvantage? Their initial cost of construction is very high. Their construction period is comparatively more in comparison to others. These requires a strong and sound foundation strata, means good and excellent quality of rock strata. Dams once constructed cannot be raised further. If the ground is weak, then requires lot of treatment and preparation, costly treatment and preparation and maintenance, etc. For the supervision of concrete dam, skilled labor is required. Normal labor cannot work for repair and for construction and post-construction. Therefore, we always require costly skilled labor. If we are going to see varieties of gravity dam, then we can further classify gravity dam based on some features in very brief. Hollow gravity dam, as the name indicates, the body of structure is hollow in nature. Empty spaces are available inside the structure. And good example, we have Iwaka Dam, we have Hatangi number 1 dam, these 2 dams in Japan, other dams also. Then the Oberoi Dam in Switzerland, these are some classical example concerned to the hollow gravity dam. Solid gravity dam, we have number of gravity dam, all are almost solid in nature to improve the gravitational force. And the solid gravity dam, one good example, solid gravity dam with curved downstream side is Hanover Dam, built on Colorado River at Arizona, Nevada, USA. This hollow gravity dam and solid, here this solid gravity dam also, Bhakra Nangal Dam. Other all the gravity dams we are generally prefer to make solid except few. Based on flow of water, the gravity dam can be categorized in 2 categories. Non-overflow gravity dam and overflow gravity dam. Very simple. Non-overflow gravity dam is a normal dam. We have no opening for proper release of water, this type. Non-overflow, we are going to provide this water inside this. Overflow dam, we are going to provide this spillway for flow above this. And in another case, we are not going to provide this. The water is present here, and we are going to provide some sluice and others for the release of water. So non-overflow dam is the Långström Dam, Luleå, northern Sweden is a classic example, and the overflow gravity dam, Bhakra Dam, Hover Dam, and this Grand Coulee Dam, many dam belongs to this. Nowadays we are more advanced in dam technology. So with this we are going to enter in arch dam. As the name indicates, it is arch in shape. Arch in shape. This convex side, this is the upstream, this is the downstream. Upstream side is a convex in nature, convex in geometry, and this downstream side is a concave in overall appearance. Similar to the gravity dam, this type of dam is also made up of concrete or masonry or sometimes steel also. As the name indicates, the principle of working or the principle of stability of this structure is based on arch action. So one by one we are going to divide different aspects of this dam in different headings. So one by one we are going to discuss. The arch dams are also made up of concrete or masonry and sometimes steel also for localized purpose. As far as geometry is concerned, the name itself explains it is arch in shape. Therefore, these are arch or curve in their shape, and in section the arch dams are relatively thin and curved in shape. This type of features we are going to see in case of arch dam, or this type of features we are going to get in arch dam. This is the section. Working principle is a very important and function. The thickness and curvature of a body of arch dam are designed in such a way that more than half of acting force or load is to be transferred to the abutment. The rest of forces is going to transfer towards the foundation, towards this ground. Therefore, the relation between this width and the thickness in case of the arch dam is found differently for different type of arch dam. We will elaborate in detail as per situation. Thus, this structure is suitable to distribute major part of forces towards the abutment. Towards the abutment side, here with the help of this cartoon you can see this arch dam, this section, this arch dam is going, the major forces are going to transfer toward the abutment. The rest of force transferred toward the bottom side at the foundation through cantilever effect. If more than 50% forces are required to transfer towards the foundation and less than 50% force is referred to transfer toward the abutment, then this type of arch structure is recognized as arch gravity dam, because the major transfer of forces is following principle of gravity dam. The shape of this dam is arch, but the major portion of load is transfer following the principle as followed by gravity dam. Therefore, this type of dam is known as arch gravity dam. Arch gravity dam self-explanatory, arch in shape and following the major portion of force or major parts of load transferred toward the foundation. Next, if we are going to see this toward the abutment of strata due to arch effect, it is the characteristic of arch to transfer the load towards the abutment. Major part of force in arch structures always transfer toward the abutment, and this is very excellent type of effect we are utilizing in case of bridge also, in case of road also, in case of many structures where The rest of the force transfer to the foundation to cantilever effect. If this rest of the force is a measure more than this transferred force, then it is arch gravity. In which condition this type of dam is recommended for construction but natural? If the major part of the force, this major part of the force is a transfer toward the abutment or valley side. This is the arch dam. This is the arch dam. The major forces due to the arch dam, construction of arch dam and water thrust, hydrostatic force and other forces. Therefore, this zone should be belonging to, or this zone should be of good to excellent quality, able to bear the load transferred by this arch action. Therefore, this valley of the location should have strong valley walls which are able to bear the transfer load due to arch action. In such abutments and foundation rocks should be sufficient strong to bear the load. The arch dam, as per principle, develop in narrow valley to avoid unnecessary use of more material. Narrow valley are canyons such that the heights are generally more than the axial length. Therefore, we generally prefer for a narrow canyons or valley. Then what is the advantage? This dam is thinner than other type of dam, thus require much less material for construction. Second thing, if much less requirement of construction material in this case, then but natural, this is economical than the gravity. Next, this type of structure is practical for the remote locations, particularly in narrow gorges area or narrow valley. Similar to the gravity dam, this arch dam can be divided in a number of categories: constant radius dam, variable radius dam, and constant arch dam and double arch dam. These divisions are based on design. However, one division can also be done based on the number of arches. So, if based on number of arches, this dam can be divided in two category or three category, particularly two, but we can utilize as a three: mono arch dam, bi-arch dam, and poly-arch dam or multi-arch dam. The design-based classification, this is self-explanatory. The design-based classification we will discuss in our next class. It requires a lot of time for the explanation and for the specification. Next type and another aspect, concerned to this disadvantage. As this structure is design based and it is excellent in design, therefore required skilled labor and need quite expertise design and contractor and other persons for construction of this type of. Initial stage of engineers, the construction of arch dam is a very challenging and difficult. The rate of construction is generally slow in comparison to other type of dam due to design complication. And next, the solid rock abutments required, solid rock and strong rock abutment required for construction of this type of dam. It means the arch dam location is not in hand of engineers for construction, but in hand of nature. The nature is going to provide some suitable location. So it is bounded by the nature, not by us. Next type of dam is a very simple dam, embankment dam. The name embankment is referred for the placement of material one by one. Here simple design I try to show. This is the supposed ground. If we are going to place the material one layer here, then second layer, after placing this first layer, we are going to compact this, then going to place second layer, then going to place third layer. After each layer, end of each layer, there is a compaction. In this way, we are going to make a trapezoidal type of structure. You can see this type of structure. Although this is presenting some different aspect, rockfill dam. So in this way, we are going to construct this type of structure. You can see the placing of layers one by one to create a trapezoidal type of section is recognized as embankment dam. Here you can see, again I try to show, this is the ground, so slightly we are going to get some cut here to stabilize this type of ground. In this way we are going to fill material, suppose this zero layer, then following by compaction of this, cleaning and preparation, then going to put another layer of earth or soil, then rolling another's, then going to put another layer, first layer, second layer, third layer, fourth layer, fifth layer. So in this way we are going to make this type of, this is embankment dam. A dam constructed of excavated natural material or industrial waste or any type of material is an embankment dam. By placing layer one by one, if more than 50% of the total volume of an embankment dam is made up of compacted fine grained material obtained from some area, subgrade or soil, it is known as earth filled dam or soil filled dam or simply earth dam. In fact, an embankment dam is a massive water barrier having a semi-permanent waterproof natural covering for its surface and dense waterproof cores. In view of the division, this embankment dam can be categorized in two categories, which we have already discussed: earth-filled dam, and if in same fashion, if we are going to place the boulder, then earth, then boulder, then earth, then you can also recognize partially rock-filled dam with horizontal placing of layers. This earth-filled dam is a pure belonging to the embankment dam. Partially this rock-filled dam also we can consider under the embankment. Here we are going to elaborate about the earth-filled dam following this concept of the embankment. This earth-filled dam can be divided in three categories: homogeneous earth-filled dam, heterogeneous or zoned earth-filled dam, and third, earth-filled dam with diaphragm. Here we have already discussed, if the whole structure is made up of homogeneous soil, it is a homogeneous earth dam. If it is a zoned, means we are having one layer here, we are having another counter layer, and in between these two we have core. So in this way this is also known as core earth dam. If this core is limited to this level and made up of concrete, this is the diaphragm structure. This portion is a diaphragm structure, and this type of dam is recognized as the earth dam or earth-filled dam with diaphragm structure. So this dam As far as condition is concerned, this dam can be constructed anywhere, in any locality, in any type of ground where other type of dams are not possible to construct. Condition. This type of dam can be constructed in any location as per availability of water and need of society nearby. What is the advantage? The major advantage, it is labor friendly. This type of dam construction is a labor friendly project where we are going to involve number of laborers, number of peoples to improve the employment of the country. Another thing, the design is a very simple and the materials are available nearby. Therefore, the transportation cost of the material handling is comparatively low in comparison to the material used for other type of dam like gravity dam, arch dam, etc. Next thing, this type of dam is utilized for multi-purpose, allowing the people for movement by using the top or crystal part as a road. What is the drawback? This type of dam or disadvantage, this type of dam involves large area. This type of dam has problem of piping due to erosion or percolation and seepage of water. This type of dam is also problematic under the effect of earthquake, showing lot of liquefactions and others. Therefore, require proper maintenance and repair time to time. This topic we have elaborated by taking the materials from different books, websites and others. The major contribution of the materials from Engineering Geology book written by Gangopadhyay S, published by Oxford University Press, then partially supported by the concept taken from Engineering Geology book written by Wells, Koshavilu about the textbook of Engineering Geology, and the Waltham related to foundation of Engineering Geology concerned to the fundamentals aspect of. We can summarize based on our discussions. Gravity dam is ideal engineering structure or engineered structure, follows the principle of gravity. Arch dams or arch dam. Arch dams are suitable for narrow valley with sound and strong rock strata of good category. Embankment dam is a trapezoidal in shape and formed due to placing of different earth layers one by one. And the earth-filled dam or earth dam is a type of embankment dam. We can consider rock-filled dam also as embankment dam if the placing of the rock and soily material one by one with respect to time. Dear friends, in this class we have discussed about gravity dam, arch dam and embankment dam in brief and in detail depending on the requirement of the topic. Rest kinds of dam we will discuss in next class in elaborate manner along with some of the dam and classification based on use and significance along with some miscellaneous type of dam. Thank you for your patience.